All right, this is the Chapter 7 question with the real estate data, and hopefully you saw how to compute the mean, which they give it to you, and the standard deviation of that data, and they want you to estimate the percentage of homes selling for more than $280, and they tell you use a normal distribution. So what this means is that the very first thing I'm going to do is draw a bell-shaped curve. Okay, so that's step one. They're saying that my data set here, my mean, which is right down the middle of a normal distribution, is $220.10. And then one standard deviation above, we have 4711, and this you don't have to do anything with this, but it's kind of nice to understand what the standard deviation even means. So if I take 221.10 and I add 4711, so in other words 221.10 plus 4711, I get 268.21. Well, what does that mean? That means I'm above the mean, okay, one standard deviation. And hopefully you kind of remembered that that had to do, if we're one standard deviation, that's 68% of the data, two standard deviations, 95% of the data, and so on. Okay, not that important to know for this problem, but it's something good to understand. So now what they said is estimate the percentage of homes selling for more than 280. Well, 280 is out here somewhere. I don't know exactly, but let's just say right there. And more than means to this side of the line. If it said less than, then I would be interested in below the line. But they didn't say less than, they said more than. So what I'm going to do is I'm going to find this area under this curve, which will in turn give me an actual percentage. Well, the only way to do that, because different data sets are going to have different means, different standard deviations, is what we end up doing is we standardize this curve here so that we can use our table, which you're going to see I have there below. We're going to use a table, but by standardizing it means I'm going to make the mean 0, and then one standard deviation would be the 4711. So my question is, if this is standardized, what is that z value right there? So that's what I'm going to find. That's my whole point here, is I need to know what this z value is. Well, we have a formula that says z equals x minus mu divided by the standard deviation. All right, your x value is your value in question, which in this case is the 280. My mean is what was given, or I calculated, 221.10. And then here's where I'm going to use that standard deviation, the 4711. Okay, so I have all this set up. I do my calculations here, and I get 1.25. So that says this z value is 1.25, which says I'm greater than one standard deviation above the standardized mean. All right, well, what good does that do me here to get this area up here? Well, this value, you go look in the back of your book. So I had 1.25. In the back of your book, there is a table that once you standardize and you have a z value, now you can look this value up. So let's look it up. I look down here for 1.2, and then I go straight across until I'm even with 0.05. I know it's a little blurry. And I get 0.3944. But we're not finished, because I want you to recognize this picture right here versus what our picture looked like. Our picture looked like this. We had 0, we got 1.25, and I wanted to find that area. Notice up here, that's the area I'm looking for, but the table shows this brown area. Again, the table shows this area here. I don't want that area. I want this area. Well, this area underneath the curve is probabilities. All probabilities have to add to 1. If you took all the probabilities underneath this normal curve, you would get 1 or 100%, okay, if you're thinking in percentages. Where the mean is cuts it in half, meaning half of my data is on this side of the mean, and half of my data is on this side of the mean. So why that's important, I could find this value here by taking 0.5 minus the value I looked up in the table. And I get this 0.1056. So what this actually is, this value, and you normally see it written out this way, this is my probability that my X is greater than $280, which I found this by finding the probability that my Z value is greater than 1.25, and again I get 0.1056. So they say to use this to actually see how many homes are selling for more than $280. Well, if you look in the spreadsheet and you see the total number of homes, okay, and I don't have the spreadsheet up here, but the total number of homes was 105. We'll take the total times this value, and this, so in other words, this is saying about 10% of the homes, and you should get 1109. Well, now actually count the homes that are over greater than 280, and I think if you count these, you should get 14. So as you can see, this isn't a great indicator, okay, or estimate here, because it is low. I mean, it's kind of, you could fudge it a little bit and say it's kind of in the ballpark, but it is kind of low, and the reason why is if you go back to your graph, it is greater than, okay, we're talking about greater than here, 1 standard deviation, because it's 1.25 standard deviations. So we might say that that's kind of too far from our actual data.